this page. So first assign oxidation numbers to determine if it's a redox reaction or not. So my first formula, SO2, I see it has oxygen. It's not bonded to fluorine. Its partner is not from group 1 or 2, so this is common oxygen, A-2. There are 2 of them. Its partner S must supply enough charge to cancel it out, so it uses A+4. My next formula, O2, it's an elemental formula, so we assign it a 0. And my final substance present, it has oxygen in it. It's not a peroxide, not bonded to fluorine, so it uses A-2. But there are 3 of them, so the collective -6 charge needs to be canceled out by the only S, so S must be using A+6. So when I take a look at this, there are definite changes in the oxidation states. This is a redox reaction. Now I need to figure out, are there any spectators? Well, this oxygen starts off with a -2, and I see the oxygens on the right end with a -2. So these oxygens did not change their oxidation state, so I'm going to put a line through it. But I also have oxygen right here that starts off with a 0, and it ends with a -2. So these oxygens show a change in the oxidation state. The sulfur starts off with a +4, ends with a +6, change in oxidation states. So only the oxygens that are part of the reactant SO2 are spectators. Now, quick reminder. LEO means losing electrons, losing negative charge, so the oxidation state goes up the ladder, where GR means gaining electrons, gaining negative charge, the oxidation state will go down that ladder. So if I take a look at this O, it starts off with a 0 and it ends with a -2. Going from 0 to -2 goes down the ladder. So the oxygens that we assigned a oxidation state of 0 with end up with an oxidation state of -2. The S starts off with a +4 and ends with a +6. So +6 is higher up the ladder than +4. So our LEO process occurs with the sulfur +4 charge. Taking a look at the next example. So in this example, the formula Na, element, so we assign it a 0. Cl2, diatomic element, assign it a 0. NaCl is a compound. So Na, the sum of their charges must be 0. Na is from group 1. Group 1 cations use a +1 charge. Cl needs to supply enough charge to cancel it out, so the Cl uses a -1. And in this case, we see a change in oxidation states. There are no spectators. So everything is participating in the electron transfer. LEO means lose electrons, lose negative charge, so we see an increase in the oxidation state. GR, gain electrons, reduction, gaining negative charge, so we see a decrease in the oxidation state. Na starts off with a 0 and it becomes a +1. So 0 to +1 means we're climbing up the ladder. So we start off with Na0, and after it is oxidized, it becomes Na+1. Cl starts off with a charge of 0 and ends with a -1, so that means it's gone down the ladder, it's gained negative charge. So the Cl starts off with a 0, and after gaining electrons, it becomes Cl-1. Last example. The nice thing about this example is that the work is done for us. In this example, oxidation states are already assigned. So oxidation states are given, so we don't have to figure those out. And the other nice thing with this is that the spectators have been left off. So the spectators have already been left off for us. So we don't have to assign oxidation numbers. We don't have to figure out if anything is a spectator. We just go straight to the analysis. So quick reminder, Leo, lose electrons, oxidation, losing negative charge, so the oxidation number is going to increase. Ger, gaining electrons, reduction, gaining negative charge, the oxidation state is going to decrease. So when I take a look at this process, I see that calcium, its oxidation state is not listed. So when that happens, we understand, and all the others are given, we understand it's starting off with an oxidation state of 0. So calcium starts with a 0 and ends at +2. So calcium's oxidation state show it climbing up the ladder. So the calcium must be losing electrons. And then when it loses the electrons, it becomes calcium +2. Titanium, Ti, starts off with a +3 charge, and it becomes titanium with a +1. +1 is going down the ladder compared to +3. So titanium 3 is being reduced to titanium 1.